Hello, guys. Hope you are doing good. My name is Avinash. With an experience of more than 6 years, I currently work for Dell Technology as a data scientist. Prior to it, I was part of IBM and Accenture, where I was into machine learning and data science. As teaching is my passion, I have been into training industry for more than 2 years now, where I provide training on data science and also on few more essential modules like Python for data science, mathematics essential for data science, and MongoDB. So far, I have trained more than 200 students and corporate folks who are well placed into data science and machine learning profile. My mode of teaching comprises of a few stages on daily basis, and I shall teach any topic in data science from scratch as I relate it with the real data science industry. And as I leverage all my real-time experience of more than 6 years to make sure that you understand each and every topic with the real-time data science industry scenario. And on top of this, I shall be sending you interview questions on daily basis for the topic we covered to make sure that you get ready for the interview on daily basis. And after the completion of the course, I'll make sure that the amount of effort we have put into our course on daily basis on learning the topics, understanding the topics, practicing the algorithms, and also the learning the interview questions at the end of the course will make sure that you are 100% ready for the market to come and crack any of the interview. And I shall also guide you on resume building process. When you are ready for the interviews, I'll help each one of you to prepare your resume according to the aspect what you're working now currently. Maybe if you are a fresher or if you are working in a company, if you are from dev profile or from testing profile or whatever. So I'll make sure that how I can mold your interview, how I can mold your resume so that that is fit and fine for any of the data science profile across the world. So let's begin with the introduction. So, well, money makes the world go around is something we must have heard for sure. But very apt saying in this today's digital revolutionary age would be data makes the world go around. Indeed, data has become fuel now. Data has become fuel for the business. Data has become a first class asset of any business, corporations, and the organizations, irrespective of their size and scale. Any intelligent system, regardless of their complexity, needs to be powered by data. And at the heart of any intelligent system, we have one or more algorithm based on data science, machine learning, deep learning, or statistical methods, so which consume this data to gather knowledge and provide intelligent insights over a period of time. So this is the time where data science becomes very significant for a career path, and it includes a lot many high paid opportunities and super fast growth. So this is the reason we say that data has become fuel of this current generation, where you can encash data as much as you can. So let's begin with the course content that we shall be covering in our course. And on top of this, any ad hoc topic or any requirement which comes in the middle of our discussions during our classes will always be most welcome. It will be welcome all the time, and we can discuss it during our classes, during our sessions. So, starting with the introduction, we will be dealing with the introduction of data science and machine learning and its aspects and its use cases, how this data science is very much related to the world scenario right now in terms of so many industries, maybe finance, maybe hospitality, maybe medical, or maybe the gaming world. So we will try to relate, we will try to understand that what is the data science, how it is related, how it is kind of in use, how it is inculcated throughout the world in any of the use cases. Frankly speaking, I don't imagine any company who in the future will not require data science as its main primary role. And the thing is that every company will want to grow its business. And in order to grow its business, obviously it will look for someone who can predict or who can let him know that what happened in the past from its data and what needs to be done in the future. So that is where the data science or the machine learning comes into picture. So We shall be covering with so many aspects of data science, starting with the data science life cycle, like how it starts, how is this flows. We will learn about what are supervised and unsupervised learning. So we will try to understand. We will try to understand with the simple example, with the example which we can relate to our real world example, which I have been working for more than 6 years. I will try to explain the real time examples. And on top of that, obviously, as I told you that at the end of the every class, I will be sending you the interview questions so that you are getting prepared for the interview for the on the daily basis. So we will be discussing so many aspects like supervised and unsupervised learning, where we will see that where we have what is the difference between supervised and unsupervised learning, where we will see that that how a particular supervised learning makes use of someone, a role model for its model to define that how the model should proceed further, and where that thing is not there in unsupervised learning, meaning you will not be having any dependent variable in case of unsupervised learning, while we'll have it in the case of supervised learning. And also followed by that, we will discuss all the ingredients which we need to study any of the algorithms, say supervised or unsupervised learning algorithms, like sample population. And we will also discuss about the data, which is our nominal data and ordinal data, and how we kind of make sure that those categorical data, how we make use of them in our data science industry. And so we know about the independent and dependent variables, which is nothing but when you say for the equation of a straight line, simple straight line, y equals to mx plus c, where y is our dependent variable and x is our independent variable. When I say independent and dependent variable, it simply means that if you say that you are independent, it means that you don't need anything from else. Same is the case with data science, or same is the case with any of the equation. When I say y equals to mx plus c, means x is something, it is called independent, it don't need anything. But y, on the left hand side, it is dependent upon the values of x. That is why it is called dependent variable. Then we will proceed further with our descriptive and exploratory analysis, which is kind of one of the main aspect of our data science, and we'll cover the topics such as visualization and like how do we kind of represent a single variable visually, how we can try to represent the relationship between two variables. We will learn about few of the charts like box plots, scatter plots, histograms, and top of this, we will be learning around 15 to 16 types of chart and bar graphs and diagrams so that we can represent our data set. So how the representation of data set comes into picture. So it's quite obvious when you get a requirement from the client, right? Your client, you are not sure that might be technical or maybe non-technical. At the end of the day, at the end of the business, the requirement would be to get the things visualized. The requirement would be to get the things visualized on what you have done for the client for 6 months, for the 1 year of time. So here the visualization comes into picture. Then we will be discussing about the univariate analysis, where we will discuss so many aspects like center tendency measures, frequency distributions. We will discuss about the spread dispersion measures and also the graphs, which we talked in our last slide. And we will be covering the skewness, where the skewness is what? Skewness is nothing like how your data is aligned towards left or right, which in our data science terminology, we say this as a left-tailed or the right-tailed, or we say positive skewness and negative skewness. We will understand that how they are kind of, how they vary from the bell curve, how they are aligned towards the right, why they are aligned towards the right, what the things we can do, what sort of methods we can apply from data science to make them aligned exactly to the center. And then we will be following with our bivariate analysis, which aspect, very important aspect, like to wave frequency table, covariance, correlations, and again the graphs, which we will be covering here as well. And again, the skewness for bivariate analysis also will cover. And like for example, when we talk about correlation, right? What we will be discussing over here is like how the two variables are correlated to each other. So for example, we have variable x and variable y, then we will try to understand if there is a positive correlation, if there is negative correlation, or if there is a neutral correlation, means there is no correlation. So meaning that for what x, for unit value of x, what is the response change in y? That is nothing but our correlation. So if I do increment of 2 into x, and the y value becomes 4 into its original value, then we can say that they are positively correlated and the value becomes double. But if, what if say I just say that the value of x becomes, when I take a value of, suppose I double the value of x and the value of y becomes negative, then that we say that both the variables are negatively correlated. So here the variables are nothing but the features in data science. They are the columns in data science. They are the columns of the data set, what we will be getting from our customer, from our client to our data science day-to-day works. And then followed by our multivariate analysis. We'll cover so many plots, very interesting plots, which are our box plots, parallel plots, and the joint plots, and the scatter plots. The scatter plots primarily are kind of very important. We will be using in probably almost every example of our data science when we discuss our algorithms. And then again, finally it will be like summarizing the data, like how do you summarize the final data set, what you got from the customer, how you depict the central tendency, and how you measure the dispersions. It will be kind of a day-to-day work for us in our data science industry. It's like after they're getting the data from the customer, after they're getting data from the client, we have to go through a thorough process. Like how do we summarize everything? How do we summarize our data set? Like what are our requirements, what are our not, what features we need to use and what not. And we shall be covering the probability distributions, which involve our random, normal, and uniform, and also the binomial and Poisson distributions. So this distributions comes into picture, when we will be studying about the data presentation in terms of the data which we got from the client, how we can depict it in terms of graph. If suppose if we talk about normal distribution, then how we kind of make sure that we are using the bell curve, and how this so that this is why it is called a Gaussian distribution, and how the data get distributed in terms of the bell curve. And we'll see that how the average observation, or how the average count of the data will be lie in the middle, signifying this as a bell curve, meaning the curve will look like a bell. So these things we will be discussing under our probability distribution. And then we will start with our inferential statistics, which will cover our estimates and confidence intervals, where we will be learning about sampling distribution estimates and confidence intervals. We will also learn something very important, that is Z critical value, which we call as Z score, and which is very much important in so many aspects of outlier detection, and also in some of the aspects of estimation and statistics. And we'll also go through our CLT, that is called the central limit theorem. We will be covering these things in terms of inferential statistics. And before going to inferential statistics, we will try to understand the difference between the descriptive statistics and inferential statistics. And then followed by the one of the very important aspect of data science, very important, that is our hypothesis testing. We will start everything from scratch. We will try to learn the heights of hypothesis testing, which we use in our real-time data science industry, which comprise of p-value, critical value, one-tailed test. Again, we will come across a z-score, which we discussed in our last slide. We will be starting about the one sample and a two sample test. We will be understanding like what is a null hypothesis, what is the alternate hypothesis. We will try to understand that how can we reject a null hypothesis, how can we kind of prove if enough evidence to get our alternate hypothesis accepted. Also we will learn that what are our kind of how confident we are, which says the level of confidence. And also we will learn what is our level of significance, where we'll see that alpha is called the level of confidence, and alpha is called the level of significance, and c is called the level of confidence. We will try to understand and derive that how alpha plus c equals to 1. And with the course of discussion, we will be discussing about the type 1 and type 2 error, which is very important aspect of any of the data science project what we work on. And then followed by our confusion matrix, the truth tables, precisions and recalls. Confusion matrix is nothing but kind of it's a sort of it's evaluation model, how you kind of evaluate your model, data science algorithm what you have written. So meaning, suppose if you had 100 observations and your algorithm predicted 90 of the predictions were 100% correct, but the 10 predictions were not correct. So that comes under the confusion matrix. So with the time, with the passage of time, we'll try to tune our hyperparameters, and we'll move further to make sure that this confusion matrix becomes lower and lower. So from 10, We'll make sure that it becomes 8, then becomes 6, then 2, and so that our accuracy becomes more and more. And then we will be covering something called as ANOVA and the F value, which is another important aspect. And under the ANOVA, we will be dealing with the one-way and the two-way ANOVA, which is another important aspect of our data science. And as I told you earlier, after the completion of every classes, I will be sending the interview questions so that you are very much ready, very much prepared for the interview on a daily basis. So you don't have to kind of spend too much of time after completion of the course just for the interview preparation. Rather, we will be ready for the interviews after the completion of the course. Simply you need to revise on the daily basis. That's it. And then in terms of the modeling, what we discussed, that we'll discuss our regression techniques and we'll see that what is our trained data, what is test data. We will understand with real-time examples how this simple linear regression and how this multiple linear regression works and what are regression coefficients. We will understand different methods of like R square, root mean squared error, and accuracy score. We will be dealing with the real-time examples. We will discuss all these regression techniques in data science algorithm terms, in terms of Python, in terms of the programming language what we will be discussing, and we'll make sure that accuracy score of our regression is well, and it's kind of will show that our accuracies keep on increasing as far we learn together. Then followed by we will discuss about the logistic regression, and which logistic regression will cover so many aspects, whereas something called as sigmoid function, the log loss, the ROC and the AUC curve, when maximum likelihood, the cross validation. So these things, when we will discuss the algorithms, we will discuss the algorithms on the basis of the real-time example on the data science industry based. We will discuss everything for logistic regression as well, and we'll make sure that the thing is left untouched while we discuss our logistic regression or any of the algorithm in our data science. And I will start everything from scratch. So I'll make sure that that any of the prerequisite is not required for my classroom. I'll make sure that whatever that is more than enough for me to make sure that you become a pro in a data science. Followed by one of the very important and very worldwidely used algorithm, the K nearest. This we will be discussing with examples and with the real-time examples. And this we will be discussing for the two techniques for regression as well as the classification. And also on top of that, we will be discussing our K-fold technique, which we use for our data science projects. And frankly speaking, this regression and the classification, they are the kind of two of the aspect of data science which is majorly used. Okay, and if you compare regression and classification, classification tops means classification is very much widely used in comparison to regression. But we will make sure that we'll get an in and out concepts of both, that is regression and classification for KNN, that is K nearest neighbor algorithm. And then followed by our support vector machines. This is the algorithm we will discuss, like why do we say the support vectors, that how do the support vectors support the entire algorithm. We will learn about what are the decision boundaries, how a decision boundary kind of separate the two classes, why we use SVM, that is support vector machine, over logistic regression. And also we'll learn about the kernel direction what we apply for our support vector machine. And then we will be dealing with our Navy-based algorithm, which is another important algorithm for data science. We will be dealing with our real-time scenario. Since I've worked on so many algorithms past 6 years, I will make sure that whatever algorithm we discuss, we will be working on the real-time data, what exactly I have used in my environment, I have used in my projects, and I'll make sure that I'll explain everything from scratch, and it will be from scratch to the top. And we will be also discussing about another important algorithm which is called k-means, and this we will be discussing for two aspects, that is for regression and as well as classification. Since I told you regression and classifications are altogether to different types of algorithm, so we will be discussing this k-means with the real-time data, with the real-time scenario, and we'll make sure that once we are done with the algorithm, I will be sharing you the interview questions so that you're getting ready on the daily basis. And then followed by the decision tree, the random forest, and the ensemble methods. We will learn, we will try to understand, we will inculcate the real-time industry examples, like how the decision tree works, what is Gini index, what is information gain. So this basically are things are something that if you are kind of trying to build a decision tree in the data science, it simply means that that's how you drill down from a root node to a leaf node. So within that, you have so many processes involved, which is Gini index, information gain, in impurity, and the entropy. So these things, what we discuss, what we will be discussing, this will be entirely based on our data science experience, what I have, and I will be discussing everything in terms of real time. And we'll make sure that we are very much versed and we are very much interview ready after the completion of every session. And then we will discuss about the ensemble methods, and which is comprising of the bagging and the boosting. So boosting, we will be discussing very much in details, so that how we can boost our algorithm. So suppose we have a data an algorithm with some sort of accuracy, and we want to make sure that our accuracy gets somewhat increased as per the request of our client. Then this ensemble methods will make sure that we'll cover thoroughly, because this is an important aspect. This is very important aspect of our data science industry. And another few more topics, what we will be discussing will be our bias and variance, and we will try to understand what is our overfitting and underfitting. So when we talk about overfitting and underfitting, is something like that when our algorithm try to during the training phase, when you try to cover each and every observation, then that case becomes an overfitting case. And the underfitting case, when we say that our algorithm is not able to cover so many points during its training phase, that is called an underfitting. And we'll make sure that we understand the exact difference between them. We will make sure that that how to get rid of this problem of overfitting and underfitting. We will be dealing everything on the basis of the real-time example, or the real-time experience, what I have worked so far. I'll make sure that whatever I teach, it will be on the real time, so that when you get into a job, when you get into the job of data science, it will be entirely the thing what we have discussed during our course of time. And then, last but never the least, each and every topic which comes an ad hoc additional topics from the students at the mid of the course, it is more than welcome. If you want to understand anything, if you want to kind of think that this might be helpful to you, this might be useful to you for the course of time, then we will be discussing everything. And again, I'm reiterating, my course stages will comprise of some of the phases like, I will teach everything on the real-time experience basis. I will deal with all the examples on the real time, and followed by after the course of completion of every day session, I'll make sure that I will be sending the interview questions so that you are getting interview ready on daily basis. And once we have completed the course, I can promise you that you will be kind of 200% ready for the data science market, and you can go for the interviews and you can crack the interviews and you can join the job. So this was all about the demo course. This was all about the course content of mine. So hope you guys to see in my classroom. Thank you so much for joining.